All right, to get started, who hates raising their hands in sessions? All right, cool. Now that we got that out of the way, how many of you have moved at least 5 times in your life? All right. How many have moved 10 times in your life? Oh. All right, so get a load of this. This is the one thing you're gonna, next week you're gonna be like, man, the one thing I remember from reInvent, it's this right here. Ready? All right, the average person between age 18 and 45 in the United States has moved 11 times. I kid you not, you're gonna wake up a week from now and you're gonna be like, this bald bearded guy told me that people moved 11 times in their life. Why do people stop moving so much after age 45? Yeah, it's painful. Your lifestyle changes. You don't have time for this. Moving can be a real pain.
Well, there's one more.
One more. Yeah, one more move for sure. So when we started our planning for this session, Arti and I were like, we really like these sessions to be fun. We'd like to figure out some way to actually make this engaging. So what do? We reach out to our product marketing person. I wanted to share with you some behind the scenes of how this actually works. So Arti emails Bianca, our amazing teammate who works in product marketing, and she's like, hey, can we get a moving truck up next to the stage? We brought the trucks in the past on stage. Could we do that? Bianca's response was like, for real? And we're like, yeah, don't worry, we won't drive it. It'll just sit there. Maybe we can get some moving boxes. And she was not reassured on this. All right, so we couldn't get moving trucks. We couldn't get boxes. What do we do? Next best thing, we used AI. About 10 prompts later, I was able to successfully generate an image that I thought was great. A huge thank you to my wife for telling me what a boho aesthetic is. I would not have known that. And my children for saying that this high key slays. So I think we have a pretty good image here. So the question you're all asking is, why in the world am I looking at an AI-generated image of a couch? The thing I want to point out here is when you're moving, the way that we move this couch versus the way that we move the books in the background versus the way we move the lamps or the plants, they're all different. It's not one size fits all for how we move all of it. The new house you're moving into may not have amazing AI-generated bookshelves in the background to put those AI-generated books on. They may have a different layout. The house may have different number of rooms, but it's all different when you're moving from point A to point B, having to try to figure that out. Typically, it's pretty easy to actually move the couch. I say that, not having moved a couch recently, but it is pretty easy to move that. It's a big fixed item. You can just lift it and you can shift it into the new location. Whereas the books, a lot of the knickknacks, the smaller items, figuring out where all of those go in the new house, that part can take a little bit of time. So as we talk about moving, it's the same thing that really happens when we're talking about moving our applications and moving our workloads from an on-prem environment into the cloud. And one thing that we really think about is that there is not a single path. There is no single way to move everything from on-prem into the cloud that makes sense for everybody. All of you may be at a completely different place in your cloud journey. You may have completely different types of workloads that need to move in completely different ways. Yes, picking up a VM, moving it from point A to point B, that part can work pretty well. It's pretty straightforward. But you may have other applications that are better suited to run on spot instances within EC2, or even different size or different capabilities within those EC2 instances. You may have cases where you can move into a serverless architecture. You could leverage Lambda. You could leverage EKS. You could use RDS and move it into managed services. The thing here is that we talk about customers not being a one-size-fits-all. There is no, we say this customer is going to lift and shift. That's really not the case. This customer may be use lift and shift for certain applications, or they may be using different methods as they go along. When we talk about these methods, if any of you have ever seen the AWS articles about the 7 Rs, there's the different methods for actually relocating. A lot of the methods I showed here fit into the 7 Rs. You can re-platform, you can refactor, you can rehost, you can relocate. There's a lot of different ways that you can go about moving these applications from point A to point B. And even the point B may be different in many cases. Point B may still be on premises. You may be able to use those workloads or run those workloads within something like an AWS Outpost, which can still run in your on-premises environment. So let's talk about one way to do that, and that's lifting and shifting from an on-premises VMware environment into a cloud-based VMware environment. So earlier this year, we launched the Amazon Elastic VMware Service. The Elastic VMware Service is the ability to take and run VMware-based workloads, the VCF stack, directly in your your AWS VPC. So just like how you would run an EC2 instance within your VPC and connect it to the environment, you can now run the VMware stack directly on AWS Metal infrastructure sitting within that environment. So this is the same VMware stack that you would run in your on-premises environment. It's not something special. It's not some modified version. We literally take the commercial off-the-shelf capabilities, the commercial off-the-shelf software, and we run that within AWS VPCs within the environment so that you're able to move from point A to point B without having to change the people skills that you have, the processes and the runbooks that they operate, and the technology that they use, whether that be third-party solutions or scripts. So from a basic feature perspective, I mentioned that this is running the standard VCF stack. So we take Cloud Builder, which is a part of the VCF stack. We gather a bunch of information from you up front. We say, hey, tell me about the underlay networks that you want to run. Tell me about the number of hosts that you want in the environment. We collect a bunch of information from you up front through the AWS console. We take that information and we actually bootstrap the Metal instances and we push the configuration into Cloud Builder and then let Cloud Builder deploy the VMware stack. So in VCF, it's basically just like how you would take those old school like CDs that used to have like the pre-configured configuration for VMware, and you pop it in and the server kind of brings itself up. It's very similar to that in the cloud world, where you give us a bunch of information ahead of time. We'll take that, we'll bootstrap the environment, we'll pass the information into Cloud Builder. It'll run and configure the environment. We hand you back the credentials, and we say, here's the credentials. Now you can log in, and you're running VMware on EC2 instances within your VPC. You can interface with this through both the AWS console and the API. So if you were to go into your AWS console and look for the EVS, you would actually find that service, and you could go in and deploy an environment and get started today. I did mention we're running on EC2 instances. These are i4i Metal instances. So this is bare metal. This is not nested virtualization or any kind of vert on vert or special hardware sitting off in the corner of our data centers. This is standard EC2 Metal infrastructure with the i4i Metal instances. Today, we do run VCF 5.2.1, and you do have access to SCDC Manager, vCenter, all the normal VMware tools that you would run on-prem. You can access those in EVS. So a really simple way of thinking about this is it's almost like using AWS Metal infrastructure like a co-location environment, but you're able to dynamically scale up and down those servers with the click of a button as opposed to ordering more hardware. You do have full administrative rights, so we do not run this as a managed service. This is completely controlled by you, the customer, just like if you were doing it in an on-premises environment. You have full admin access. You can get and do really just about anything in this environment that you could do in an on-premises environment. From a consumption perspective, you do have the ability to deploy instances using instance savings plans. So if you wanted to commit at a 1-year interval or consume on demand or even 3-year intervals, you do have flexibility and choice as far as how you consume those instances. And we do operate in a bring your own subscription model. So going forward, kind of in all cloud providers running VMware, it is a bring your own subscription model. So you can take the existing VCF subscriptions that you have on premises, you can bring those with you, and you can apply those and use those into the EVS environment. And then choice. You do have the ability to run these yourself, or you can engage a partner. We worked with a lot of partners who have built managed services where they can come in and operate this for you in AWS, just like you would do in an on-premises environment. From a scale perspective, we launched EVS back in August, and we had 6 regions available. We're now up to 12 regions, and we're continuing to launch more regions later this year, as well as going into next year. So you'll continue to see us work in getting EVS launched into all AWS regions over the next few months. I mentioned briefly kind of the customer managed versus partner managed. This is a big deal for a lot of customers who are maybe moving to the cloud and they have had on-premises managed service provider partners that they were using who are no longer a part of Broadcom's managed service provider program. In that case, you are able to move into EVS and leverage third-party partners who are still in that program. They've built up, they have a lot of expertise with running in EC2 environments, running inside of AWS, and they have a lot of expertise running in VMware environments. And so there's just a lot of partners that you can leverage to do that, or you have the choice to do it yourself. The big thing here is there's a lot of offerings out there that force you into a managed model. They force to say, hey, you don't have full administrative access. You're operating in a delegated model. In our case, we have built this as a customer managed solution first, So by default, you have access to everything, and then you can bring in a partner if you would like them to run and operate the environment on your behalf. Quickly just mentioning some of those partners, it's not just the managed service provider partners like that we have here shown at the top, but also on the ISV side. A lot of the tools that you use in your on-premises data centers will operate just the same way in EVS. Think of things like NetApp or Pure Storage or Veeam. A common thing we used to hear from customers is, hey, when I move to the cloud, it's not just about moving the workloads. I have to now suddenly reevaluate all these solutions that I'm using. My backup provider, my DR provider, I have my security tools, like all these things that I've built and integrated into my environment. I now have to reevaluate how I'm going to do those in the cloud. When you lift and shift with EVS, pick up those workloads, move them from VMware to VMware, you can keep the people, the processes, and the technology exactly the same as what you had on premises because you're still using a VMware environment. So kind of going back to that moving metaphor that we talked about in the beginning, imagine like you have a house and your house is kind of out in the country a little bit and you have a whole bunch of land. So you have a whole bunch of space available to where if you wanted to build things, you could. You could build a bakery, you could build a store, you could build whatever you wanted. You have tons of space, but ultimately you have to build it yourself. Now think about moving into a destination where you're a part of a vibrant village, a community that has all of these things already in there. You already have a baker, you already have a grocer, there's a hardware shop. All of these things exist in this village, and now it's walkable. You can just walk over and interface with these things without having to go and build it yourself. That's really the way you think about scaling and operating in a VMware environment in AWS. You're taking the same house, the same floor plan, everything that you had before, and you're able to move that into a community that now has all of these other capabilities. So you can take this workload that you were running in VMware, and now it's sitting in your VPC. You have RDS that you're running in your VPC. You have S3, you have EFS. You have all these other cloud capabilities that are now sitting co-resident in the same environment with your VMware-based workloads. And we see a lot of customers do this. They'll take a database, for example, that's running on a VM inside of VMware, and they may move that over to RDS. But the application itself is still running in VMware on a VM. If the application is really, really hard to transform or modernize or change, we are totally fine with being able to have you run that workload in VMware. In fact, if you have workloads that you plan on keeping in VMware, we want to be the best place in the world for you to run those VMware-based workloads. If, when you move that into the cloud, you want to expand and extend that application to be able to interface with other AWS workloads, we want you to have that capability as well. All right, I'm going to hand it over to Arti, and she's going to talk a little bit about the building blocks of EVS.
Thank you, Andy. While our product marketing person was not able to get us the couch or the truck, we got a good Monday session that I requested for. The primary reason is what I'll be doing the next few minutes is talking about the 3 key building blocks that make up the service. This is an introductory level session, and then we have some great deeper dives throughout the week that you can go in and plug into as you want to learn more about the storage or networking, etc. Andy touched upon this. I want to spend a couple of minutes here. When EVS deploys the VCF stack, we get in inputs from you, and if you've deployed a cloud builder on VCF stack on premises, you would see that the cloud builder requires certain inputs, and that's all the service is doing. We collect all these inputs from you and take care of the deployment. It is a fully self-managed service, minus the initial deployment. We wanted to kind of remove that deployment from you and take care of it on behalf of you. So when the stack is deployed, you get all these components deployed from SDDC Manager to the ESXi hypervisor to storage to networking. But we also take care, and as you'll see when we talk about the building blocks, the underlying connectivity and storage options for you depending on your use case and your application needs. When we deploy the stack, we deploy it in a single consolidated domain, but of course there's flexibility for you as you deploy more hosts, and you can bring up additional clusters. You can do multiple workload domains. We deploy, I kept saying we deploy. EVS service deploys the environment for you in your AWS account in a VPC that you choose. So obviously, from a security standpoint, the AWS shared responsibility model is still applicable. Where it varies is We, as in AWS, are responsible for the underlying AWS components that you see here. So this means from a region availability standpoint or an availability zone standpoint, we take care of that. We also take care of capacity for you. So you place in a capacity request reservation saying, hey, I need 10 hosts by a specific date, and we enable that capacity into your account. But anything upward of the hypervisor, the ESXi stack upwards, is your responsibility. That means you're responsible for patching your environment. You're responsible for updates, et cetera. So there's 3 key building blocks that I kept mentioning. The first one, obviously, is compute. We started with i4i.metal as our first instance type. This is a bare metal instance where we deploy the environment on. We have a good history with i4i.metal. For some of you who are familiar with the VMware Cloud on AWS, the managed service, we utilized i4i.metal. We've received good feedback from customers across various use cases of their applications. These instances also go through a full certification with Broadcom. So today, if you go into the Broadcom compatibility guide, you will see Amazon i4i.metal listed as a certified instance to run VCF 5.2.1. So we do go through the entire service certification, storage, and network certification with Broadcom. Our goal, we launched with 1 instance type, and our goal is eventually to get every metal instance that's available on the AWS portfolio available for you, so you can choose based on, hey, I do have a high memory workload, so I need more memory versus compute. So that's our goal, and it's on our roadmap. Andy talked about scaling. So if you think about how do you scale this environment that we deploy, think of the EVS stack that we deploy, the environment as a top-level construct. Within the environment, we take care of that first cluster that you see here. It's a 4-host minimum. 4-host minimum. This comes from the VCF requirement that we have. And every environment can have up to 16 hosts. We've tested up to 16 hosts and are satisfied with the performance, and we are slowly expanding this number of hosts soon as well. You could have up to 16 hosts, and you could have this as multiple clusters as well within that environment. If you have a requirement to scale beyond 16 hosts today, you could obviously create multiple environments, and these environments can communicate to each other using a transit gateway. The next building block is storage. So the i4i.metal instances come with 30 terabytes of local NVMe storage, which is what we use for the primary storage, which is vSAN in this case. We are using the ESA, the Express Storage architecture, which gives a better performance compared to the OSA architecture. So vSAN forms the primary storage that is available. What we've also had feedback from customers is, hey, I want to make sure this is consistent with my on-premises experience. And so if you're doing storage policy-based management on-premises, you want to control what your RAID levels are or what your failure to tolerance is. All that's still possible. You could log in to your vCenter console once the environment is deployed for you, and you can configure these as you would do on-premises. One of the feedback we've received when we started running private preview and then we moved into a public preview is scalability on storage. Not a lot of workloads need that compute, but are more storage intensive. So we've partnered with our internal service, the Amazon FSx for NetApp ONTAP, as an additional storage option. The primary storage is still vSAN, but you could create additional data stores using NetApp ONTAP. Or Andy talked, you have full administrative access to this EVS environment, which means if you're using ISV solutions on premises like Veeam or pure cloud storage, for example, you have the ability to integrate with these storage vendors as well, depending on your application needs. So if you take a look at how this fits with FSx ONTAP, FSx for NetApp ONTAP, the primary storage is still our vSAN data store. You could create an additional file system and mount it to your ESXi host, and that could be either using NFS or iSCSI, depending on the protocol. And it becomes your additional storage. So for customers who do not want to just increase the number of hosts primarily because of storage reasons. You could have your minimum number of hosts and then work with either ISV vendors or FSx for NetApp ONTAP to increase the storage. How does this look like? So if you take a look at this diagram here, customer VPC is your VPC. The EVS environment gets deployed inside this VPC. You can go ahead into your AWS account, create a file share in FSx for NetApp ONTAP. And as long as you enable the right security group permissions, you have access to these file systems. So this is using NFS. The same architecture is available for iSCSI as well. You create the LUNs and then have security group permissions so that you can have traffic going both ways. The third building block is networking. We've done a lot of work here. I mentioned in the beginning, when we deploy the environment, we deploy it, we take care of storage and networking. What it also means is, traditionally, AWS has always been a flat layer 3 network. We have a VPC, you deploy a CIDR block, you have subnets, great. As we started to build EVS, we also wanted to see how do we bring this VLAN subnet concept into VPC. So we've taken care of that. What we've done is, Andy mentioned when he started, there's overlay networks, there's underlay networks, et cetera. So as part of the deployment, we take care of that networking for you so you don't have to worry. All you have to provide us is inputs on what your appliance IP address spacing should be. And a key part of that is also using some of the existing AWS features that are available. As you think about your EVS environment, you probably are going to connect on-premises to talk to an VMware environment that's there, or you want to maintain a hybrid environment. So we've used the existing AWS route server functionality. Think of it as a BGP propagation mechanism. What it does is you've got a lot of IPs, underlay IPs, overlay IPs, et cetera. This is like your VM IP spaces or your appliance IPs. So the route server basically enables BGP communication. It acts as a BGP endpoint between your NSX edge and all your route tables, propagates your route table so you don't have to worry about any of those failovers or like IP addressing going in and adding static routes into your route table. And if you take a step back of the full external connectivity, you can have multiple EVS environments as part of your VPC, as part of in a region. You can also have other workloads that you're running within the same VPC as well. And then I mentioned all this connects into a transit gateway. And then from the transit gateway, you could either have a direct connect or a VPN connection back to your on-premises network. So it enables the full end-to-end connectivity. I'll quickly touch upon pricing. So we talked about, Andy mentioned, we are operating in a bring your own license or bring your own subscription model. So what do you pay for AWS? The first one is the actual instance cost. So this is the EC2 instance that you're running. Today it's a 4-host minimum. All your existing savings plan and reserved instance concept still applies to it. This is a standard EC2 instance. We're not doing anything out of the ordinary here. The second is that VPC route server endpoints. You do require 2 VPC route server endpoints per environment. So you do have a cost that's associated to take care of it. And finally is the service control plane fee itself. This is where it takes care of the service itself, takes care of the deployment, the underlying connectivity between your appliances to our VPC space, et cetera. So there is a hourly fee built for this environment. So these are the 3 dimensions that you will incur as part of an EVS pricing model. With that, I will pause. It's always good to hear from customers. So we've been working with Jignesh from NYU Langone for the last several months now. I'd love to invite Jignesh to share their journey with you.
Thank you, Aarti. Hello, everyone. Jignesh Shah, Manager of Cloud Engineering over at NYU Langone Health. I'd like to start off with a number, 320. That's the average number of days it takes for an enterprise application to migrate to the cloud. I'll be talking about how NYU was able to bring that number down. A little bit about who we are. A large academic healthcare system based out of New York City. Our mission is to provide world-class patient care, innovative research, and a top-notch medical school. And yes, the medical school is free if you can manage to get in. The three pillars, patient care, research, and the medical school, that's really powered by the world-class technology that we provide to support it with the help of partners like AWS. Some key facts and statistics. We've been number one for quite some time for the best outcomes, constantly ranked on the top for several subspecialties, whether it's neurosurgery, orthopedic, pediatric, we are up there. We have about 5 large campuses in the 5 boroughs, along with close to 400 outpatient centers. We see about 2 million outpatient visits every day. And in terms of number of employees, we are close to about 53,000 in total employees. So quite large academia. Okay, so our adoption of EVS. I remember it was a few months ago, I was watching Monday Night Football with my son. I think it was Giants versus Eagles, and I get a phone call from my boss. And he says, we have to go down from taking months to weeks to migrate our applications. So the first thought, I wanted to tell my boss that you're crazy, it's impossible. But in turn, next morning, we huddled. I called my team, and we have smart cloud architects, security analysts, SRE engineers, and I challenged them to find a solution to accelerate our journey to the cloud. And being a VMware shop on-prem, it was a natural transition to go to something VMC in one of the hyperscalers. So we started contacting different hyperscalers. We came up with a comprehensive success criteria, and it was really detailed success criteria, all the way from security to chaos engineering. We had everything in it. Few months later, we had a breakthrough with EVS. And I'll go through some of the reasons why we chose EVS, what resonated the most with us. But first, our business case, it was accelerate migration to the cloud. How can we go from months to just few weeks? And also, can we leverage cloud for business continuity? As you can imagine, being a healthcare system, our uptime is absolutely crucial. So business continuity was one of the biggest use case. Some of the business requirements, we wanted to maintain control. Like Arti and Andy mentioned, we get administrative control over the vSphere clusters running in EVS. We can bring our operational cadence, how we patch, how we monitor, observability, security. We were able to extend what we do on-prem to the cloud and make it more of a hybrid. Flexible licensing model. One of the requirements was to bring your own license. So we were able to bring our existing VCF license into EVS. Multi-layer security, because we are able to run in our own VPC, not only we could use our existing security guardrails like SCPs, RCPs, but we could also extend our NSX security to the cloud. So it was really transformative when we saw that was possible. Minimizing staff turnover. One of the requirements that our management had was we don't want people leaving us. Leverage existing skill set and then slowly upskill as needed. There was one, and then EVS made that happen. Obviously, reducing capital expenditure. We wanted to go from more of a CapEx to an OpEx model. So not having to spend to buy hardwares and servers or lease data centers. EVS becomes an OpEx model, is billed hourly, we are able to cost manage it. So that was one of the requirements around reducing capital expenditure. Why did we choose EVS? Like I mentioned, we're able to run this in our own VPC. Some of the other competing solutions, we were tied into the vendor-managed VPC, not giving us enough visibility or control over what's happening behind the scenes and what we could do. Provisioning infrastructure as a code. We are big into provisioning everything as a code. So we wanted to leverage our existing CI/CD pipelines for anything that we deploy in the cloud, and EVS had that offering. I talk about bring our own VCF license, starting with a pilot light. Another welcome and a great feature of EVS is we can start with a small pilot light cluster, and then we can add nodes as needed. So you can start with as small as a 4-node cluster, and then you can add and scale up as you migrate applications or you put disaster recovery workloads in it. And on demand, we could scale out the number of nodes in the cluster in an event of a disaster. Growing ISV partners. Because we are a heterogeneous environment on-prem, it was important for us to maintain the partner ecosystem that we use on-prem, whether it's Pure Storage or it's FSx on NetApp. We wanted to keep our partner ecosystem intact and have as little changes as possible when we move the applications. Automated security provisioning, we're able to continue using some of our security tools that monitor communications and traffic, and they take action when they see an anomaly or a threat detection. So we were able to leverage and continue automating security. And the last one is one flat rate per node. We are really paying per node. You're not paying per VM or per EC2 instance. We are able to run as many VMs as we wish on a single EVS node. And that was really, really useful to our use case. Okay, lessons learned. Although this was a successful journey, we did run into some bumps in the road. And with the help of AWS support, the account team, and our OEM partners, we were able to quickly overcome some of those hurdles. One was operationalizing EVS. We had to figure out a way and build a custom module to integrate EVS availability and performance with our service management back on-prem. Things like monitoring FSx NetApp performance or integrating Veeam with our ticketing system. There was a learning curve, and it took some time to really operationalize EVS. One of one of the issue we had was figuring out routing, network routing between the EVS overlay and the VPC underlay. Because we have a sophisticated network topology, it took us a little while to figure out routing and put those policies in place to get the overlay VMs working with the underlay services such as EC2 as well as the on-prem applications. Data ingress cost. AWS always says data in is free, data out will cost you money. But in this case, it was a bit of a surprise, but we did see some ingress cost, but we were able to work with our AWS account team and bring that cost in control. And CloudFormation, because we are not a CloudFormation shop, there was a learning curve for the NYU team to use CloudFormation to provision EVS. Looking ahead, today EVS supports single AZ, so we are looking forward to a multi-AZ support. They already have multi-region support. Looking forward to them inviting and certifying more ISV partners as this ecosystem grows, and looking towards a Terraform support for EVS. And back to Aarti.
Thank you. Appreciate you sharing your journey, Jignesh. So we'll jump into a quick demo. I'll walk you through the actual deployment experience. OK, so this is the landing page in the AWS console. So as you can see, when you go into Get Started, there's a few things here. Before deployment, I think we want to make sure there's a lot of information we collect from you. Business level support is minimum required as part of having EVS. But we also want to make sure, as you think about how to get started, there's prerequisites. So we provide you all this information in terms of what prerequisites are required. That helps you with planning, because most customers that we've talked to, their on-premises team and their cloud team are different. There's a separate network team that handles like IP address spacing. So it's important to understand what these prerequisites are. So you'll see all that here. It's divided into like a 4 portion of what we need. EVS also interacts, as you saw, compute, network, storage. It spans across other AWS services. So we've provided links to other services that you'll interact with. So if you go into environments and go into create environment, so you'll see here, you'll have to give in a name for your environment. And then this is where we collect some basic information. We're starting with VCF version 5.2.1. And then as part of your agreement with Broadcom, you would have a site ID. So you'd give in a site ID and provide the solution key and the vSAN license key. It's important we do checks for this solution key and license key. What this means is you want to make sure you have, if you're deploying a 4-node environment, you have enough cores to support as part of this key that you are having. So once you give in the solution key and license key, and then the next page is where you deploy the host itself. So these are the EC2 instances. This is the compute that I was talking about. So the initial cluster, as I mentioned, is a 4-host minimum. And this is all deployed, as Jignesh was talking, in a single availability zone. You do have other options of choosing placement group settings, et cetera. But you can go ahead and create all the 4 hosts here. And then we go into the actual network configuration. We launched this feature very recently. For customers that are familiar, HCX enables you with migration of your VMs from on-premises into EVS. And you could do it over private connectivity, either using a direct connect or using internet connectivity. So both these options are available for you. So this is where you tell us, hey, this is my VPC that I want the EVS environment to be in. So you select your VPC. And then you select what we call a service access subnet. So EVS deploys it into your account, so we will have a service access into your particular subnet that you choose and what security group that you select. And this is a subnet that we'll use. And this model is very typical to other AWS services like the network load balancer or RDS, for example. Next comes the actual VCF connectivity options. So we deploy these stacks, so which means we also take care of deploying these management appliances for you. So what we do is, and this is part of the prerequisite from an IP planning perspective, is for you to give us what CIDR blocks are required in order for us to use that as part of the Cloud Builder deployment. So once you get all those IP addresses, as you can see here, I've pre-filled some of these things. And this is where you select what that route server. You would have to create your route server endpoint and tell us which route server peering to use. So you could select the route server peerings here, and then go into your next. And then this is standard DNS host name. So if you're using, you could either use Route 53 or your on-premises DNS. We ask for DNS host names for your appliances. So once you get your DNS host names, and the last page is just tags. So you'll see, you'll have an ability to review all these settings. It's important to note some of those IP addresses for those appliances. You cannot come and edit it, so it's important to just be sure you are filling in the right information as you go through this. So once you give us this, we collect all of this, and our control plane, our service, takes care of all this, bootstrapping this information, and deploying it for you. The typical deployment time today is approximately anywhere from it takes approximately 3 hours. And this involves building the VCF stack, getting the host up and running. So at the end, when you see the environment, when we hand it off to you, it is in a fully, you can immediately log into your vCenter or vSphere. Credentials are managed in KMS. So I've just recorded this so that I can show you, but let me just show you an environment that I've created to show. So this is an environment that I've created. So you would see here that the details of the environment are here, but this is what you gave us. So you gave us what the hosts are, what the keys are. So we go ahead and you'll see this is a standard EC2 instance. It's got an instance ID associated with it. So we deploy these hosts for you. You will also see this is where you provided us your network configurations from your VPC to what service access subnet and route server, and then you'll see the VLANs that we've created for you. So these are the 10 VLANs that Amazon, you will see this in your account, and these are created in a special subnet that you see here. And then the DNS host names are also available.
For anybody who's done a deployment on premises, these VLANs all probably look very familiar to you, right? This is the same thing that you would deploy in an on-prem environment. So really, the difference here is rather than racking and stacking, cabling, having your network team configure everything, you're providing just the logical information, the IP subnets, those types of things, clicking deploy. But this is nothing kind of special from a cloud perspective. This is really the same stuff you would use in an on-premises deployment.
And then you should be able to log in. Once this is available in your account, you should be able to log into your SDC manager or NSX manager and continue your day 2 operations like you would normally do. So that wraps up our demo. We do have a lineup of sessions this week, and as I was talking earlier, this is an introductory level session, but you can see here, there's very specific storage-based sessions or networking-based sessions that are related to EVS and migrations throughout the week. So feel free to take a look at some of these sessions. Some of the chalk talks are not going to be recorded, so I highly recommend doing some of these chalk talks. These are smaller sessions where you can dive as much as detail as you want, depending on what you have. We do have a getting started guide and that deployment prerequisite checklist that I was talking about. So take a look at it. And Andy and I, we do this session every year. So if you have any feedback, we take it very seriously. So please make sure to give us some feedback. It should be available on the app. We're going to be hanging out after this session. We do have some time, so happy to take some Q&A as well. Jignesh is also going to be here. So if you want to talk to us, any of us, come chat with us. And really appreciate, I know it's a long week. There's a lot of other fun announcements. The only AI we could include in our session is Andy's couch. But there's a lot of good announcements and keynotes coming up, so appreciate all of you showing up on a Monday morning to this session. Thank you.
A couple of big takeaways or things I just want you to think about as you're leaving. One of the questions we get asked a lot as we're talking with folks is when would I want to use this? And as Jignesh mentioned, a key thing for when you want to consider EVS is when speed matters. Arthi and I have conversations, I think, probably at least once a week, if not more, where customers say, my data center contract is coming up for renewal, and I need to be completely out of my data center in 6 months. Or my server support is running up in 3 months, and I need to be out of it very quickly. So a big case for using EVS when speed matters, when you need to move from point A to point B very, very quickly. This is definitely the fastest way to get from point A to point B while maintaining all the kind of people, process, and technology aspects of it that are the same. And some of the real secret sauce of this, what allows this to happen is you do not have to, we didn't cover this tremendously in the networking, but I would encourage you to go to the deep dive sessions if you can. Some of the kind of real magic of this is the ability to actually extend those layer 2 networks from your on-premises environments into the cloud. This means you do not have to change the IP addresses of the VMs as you move them. And when we talk with customers, this is one of the biggest things that they come up with is if I don't have to change the IP addresses, it reduces my testing burden, it allows my app teams to do less work, and I can move much, much faster. Again, we were trying to provide much of a higher level. This is what it is and how it works at a very high level. If you can attend some of those deep dive sessions, they'll go into a lot more detail of some of the magic behind this and being able to literally use VMware's HCX technology to move a VM from on-premises into the cloud without changing IP addresses, with very, very minimal downtime, and being able to do that very quickly. So I encourage you guys to check that out, and I'll just echo what Arthi says. Thank you so much. We would really, really appreciate it if you could provide us feedback. We hope you learned something, and again, we'll hang out down here, and we're happy to answer any questions that you have. Thank you all. Have a great rest of your week.
Thank you.